Thank you, Rajul, and thank you all for joining us this afternoon. My job is to set the stage and to provide a big picture of some of the major trends and challenges that the world faces in relation to climate change and food security as we move towards the COP, as Rajul said, later this month. I'd like to acknowledge that this work draws on a large team here at IFPRI, as well as colleagues across the CGIAR system, and to thank our principal donors, the CGIAR Research Program on Policies, Institutions, and Markets, as well as the Research Program on Climate Change, Agriculture, and Food Security, and the Bill and Melinda Gates Foundation. So our work and the results that I'll be sharing this afternoon are based on an integrated system of models. And at the core of that is the impact model, which was developed and has been refined here at IFPRI over the last 20 years or so. And that's a global economic model focusing on the agricultural sector. But it's only one component of a system of models that also brings together crop models, water models, climate models, and draws on data from a variety of sources to provide a picture of how the many and complicated variables in this system interact. The work is led here at IFPRI, but as I mentioned, we collaborate closely with colleagues in all 15 of the CGIAR centers through this program called Global Futures and Strategic Foresight. And we also collaborate closely with other global economic modeling groups around the world through the Agricultural Model Intercomparison and Improvement Project, or AgMIP. So the work that we do here draws on a strong base of expertise that is distributed across many institutions. I'll start just by introducing briefly some of the main drivers that we have to consider as we look ahead at the impacts of climate change. And of course, we start with the climate drivers. And the global modeling community uses these terms called representative concentration pathways, or RCPs. You may have heard of those. Those are just standardized scenarios of different climate pathways. All of the projections that we'll talk about depend on a large number of assumptions about how rapidly climate changes and other variables. And so I want to just briefly introduce those. They talk in these representative concentration pathways in terms of radiative forcing and carbon dioxide equivalents, but what most of us think about are temperatures, or degrees of warming in global temperatures. So I don't have a graph for that, I'm sorry, but these do correspond roughly to different ranges of temperatures, and yes, I do have a pointer here. I can make it work. There we go. The radiative forcing, there are a range of scenarios from the more rapid emissions pathways to the more optimistic ones at the lower end. The lower one corresponds to a warming of about 1 degree Celsius by the end of this century. And some of you may have read recently a new study that was released just in the past couple of days that says this year, 2015, we're already on the verge of a 1 degree increase over the past century. So that indicates that that particular scenario is, extremely optimistic. The intermediate scenarios range from 1 to 2, 2 to 3 degrees, then all the way to the highest one, which corresponds to a warming of 3 to 5 degrees Celsius by the end of this century. And the indications are of the commitments that countries have made going into the COP later this month. Those commitments collectively correspond to an increase that's estimated at around 2.7 degrees Celsius. So that puts us actually towards the upper end of this spectrum. And in a lot of what I'll be sharing in this presentation, I'll be talking about a scenario that corresponds accordingly to that highest emissions pathway, RCP 8.5. Alongside the climate assumptions, we also have to make assumptions about how rapidly the world is going to change in other dimensions. And in principle, we look at changes in population growth and changes in economic growth. And again, the global economic modeling community, in order to facilitate comparison, has come up with some standardized scenarios or pathways representing different socioeconomic trajectories to help facilitate comparison across different analyses. And again, there's a range. I won't go into the details, but from more optimistic assumptions about population growth to more rapid assumptions, and likewise to slower economic growth and faster economic growth. Most of what I'll be talking about in terms of these socioeconomic scenarios today is in this intermediate case here, and specifically SSP2. Importantly, while these projections or these scenarios are defined out to 2100, Our own analysis focuses on a time horizon of 2050, just because in order to make it real and to make it relevant to decision makers, we have to bring it closer to decisions that are made today, because all of these factors are things which have a lot of inertia and require analysis and policy decisions today in order to have impacts over the longer term. So here, just to start out with, is a picture of our projections of changes in global production of the major cereals. And this is in 2050. This is before we consider the impact of climate change, and it incorporates that intermediate socioeconomic scenario. Each bubble here corresponds to a particular crop, and the magnitude of that bubble shows the projected increase in production by 2050 relative to 2010. So the maize, the largest one that you see here, the size of that bubble corresponds to about 500 million tons of additional production projected by 2050. That's about a half again as much as the world produces today. The position of these bubbles on the graph is also important. On the horizontal axis, what you see, you may not be able to read the label there, but it corresponds to harvested area. So the farther a bubble is to the right, the more that growth in production relies on an increase in area. In the case of maize, about a 20% projected increase in area by 2050. And likewise, the vertical axis corresponds to the projected increase in yields. And again, for the example of maize, that corresponds to an increase of about 40% on global average in maize yields. You'll notice that all of the bubbles, regardless of their size and position, are above the 45-degree line. And that just continues the historic pattern that most of the growth in production is going to come from yield increases rather than area increases. But obviously, crops do vary. I won't show you other regions, but you do see differences by region. Of course, in Latin America and Sub-Saharan Africa, there tends to be a shift to the right, a relatively greater reliance on area, but still a predominant reliance on increases in yield. And of course, it also varies by commodity. So what about the impact of climate change? These are projections from crop models of the potential change in yield due to one particular climate scenario. This uses a climate model from the UK and this high emissions pathway, RCP 8.5, and shows the distribution of projected losses in yields of rain-fed maize in particular. This is just one example. We would see a slightly different picture for other commodities. In the case of wheat, for example, you would see more blue at the higher latitudes corresponding to areas where climate change and global warming could actually improve growing conditions and increase yields. But in this case, the potential impacts for rain-fed maize, as you can see by the red color, are quite severe. Now, it's important to note that these are simulation results from crop models. So that's before economic responses are incorporated. And those economic responses are critical because what we would expect from a picture like this is that other economic variables would change, and that would trigger then a set of reactions. So one of the changes we would expect would be an increase in prices of maize, and that in turn would induce not only innovation and increased yields on land already in production, but it would also trigger an incentive to increase the area under production. So these are some of the factors that we then look at with this integrated system of models, not just the crop models, but the economic models and the other components that I mentioned earlier. And when we bring those together, here's a picture of what climate change impacts on yields would look like by region in 2050. Now this is, in the case of SSP2, an intermediate sort of population and income scenario, but comparing the possible impacts of different climate scenarios. So what you see in the gray bars here are the projected yield increases for cereals as an aggregate for different regions between 2010 and 2050. So you'd see, for example, at the world level, about 40% increase, as I mentioned a little bit earlier. The dots represent different levels of climate change. And so those climate change, depending on the region, might reduce the projected increases in yields, or in some cases they might actually improve, further increase those projections. What's interesting is the distribution of those. So we see a couple cases that stand out here. Europe, former Soviet Union, higher latitude producers. Those are areas where climate change, on average, in the case of cereals, actually improves growing conditions, and we see an increase in yields beyond what we would expect in the absence of climate change. But the opposite is true for many other regions, particularly South Asia, Sub-Saharan Africa, Latin America to a certain extent, but the point is it varies significantly across regions. And the pattern tends to be the higher latitudes, which are generally the more developed countries, are more likely to benefit, and the lower latitudes, the tropical countries, which are more likely to be developing countries, are the ones that are penalized by climate change. This is the case for cereals. There are similar pictures for other commodities. I won't go through them in any detail, other than to note that the same general pattern prevails in each case. So I mentioned prices earlier, and I'd like to come back to that briefly, just to compare the relative impact of socioeconomic drivers versus climate drivers, in this case for the example of cereals. At the bottom graph, we see the impact on cereal prices of different assumptions about population and economic growth. And it's not important to go into those in any detail right now. But what is interesting is that when we compare that, and in the top graph here, this bold line corresponds to the intermediate population and income growth assumption, which is also in dark blue here. If we go up here and look at different climate scenarios, we see that under that scenario, in the absence of climate change, we would expect about a 20% increase in real prices between now and 2050. But climate change on the magnitude, the rough order of magnitude expected, would approximately double those price impacts. So that's a significant implication directly in terms of access to food for poor people, but also in terms of feedback and in terms of incentives to modify production practices. And I'll just note that it's quite a different picture for different commodity groups. In this case, when we compare meats, we see smaller impacts directly as a result of climate change. That's partly a result of the limitations we have in our modeling at the moment, but it's also a result of the fact that those impacts on meat production and prices are mediated through markets for cereals, and those have enough adjustment and substitution potential between different scenarios to somewhat mitigate those price impacts. Whereas by contrast, the outcomes for meat prices are much more sensitive to different socioeconomic assumptions, and that's as we would expect. A commodity like that, where the demand is very sensitive to not only prices but to changes in income, we would expect to see very sensitive to socioeconomic drivers. And so those are important things to incorporate. I'm going to skip through some of these, briefly growth in total global demand, just to show that the staples are growing more slowly, the higher value commodities growing more rapidly. We can also see that in terms of the composition of the food supply. This breaks it down by region. And without going into too much detail, you see the greens and the blues there. Those are oils and sugar, animal products, particularly in East Asia and in smaller in absolute terms, but these are large populations in South Asia and Sub-Saharan Africa, also increases in those commodity groups, which have important implications for diet and health. Trade is critical in mediating the impacts of climate change. Here we see, in the case of cereals, North America, the gray bar shows the level of net exports today. We see a potential to increase rapidly. Imports increasing in South Asia and Sub-Saharan Africa. Those depend on different climate scenarios assumed. These also have implications for the population at risk of hunger. This corresponds to FAO's undernourishment numbers. In short, significant improvements in the absence of climate change, but those will be reversed to a certain extent by climate change, and potentially about 40 million people in Africa, Asia, and Latin America with the potential to become or to remain food insecure because of climate change. We're doing things about it. We're doing research on different crop technologies. We're doing research on different management practices which have the potential to mitigate these impacts, but these depend critically on the amount of research that's invested in these alternatives. And I will conclude there just to say that there are important impacts that differ significantly by region. Economic responses have the potential to reduce those impacts, but those economic responses depend critically on policy and market conditions, and those in turn are driven by decisions that we make today. So challenges at global level, decisions that are required at national and smaller scales. And with that, I'm going to turn it over to Alex, who will pick it up and tell us more about what's going on at the country level. Thank you very much.